the parts one by one, and then you can also understand what I'm trying to say. Yeah, just give me 1 second.
Yes, it is not a problem, Abhishek. I am recording this meeting, so I will share it with the teachers after
Then they
this.
can,
So then they
after the
can follow
session, they
it
can.
when they have the kit. They can follow it.
Okay, okay. Just give me 1 second.
Teachers, please, if you can uh, show your camera so that he will understand whether you're understanding or not.
Yeah, body language
Yeah.
part of it. Yes. So what I'll do, let me just quickly get my presentation. In the meanwhile, just I wanted to know from the teachers, have you all worked with robotics before this, or is this your first time?
So this is first time only.
At the first time, okay.
Yes.
All right. I think then I think we can start from the basics only. And what I can do, I'll go a little slowly also, so that you understand the concepts one by one. Okay. So, but before we start, let me quickly, I have a few questions before we start. Okay, and that is pertaining to what robotics is. Sorry, just give me a second. Uh, I hope the screen sharing is allowed. Okay.
Yes, let me check. I will.
Yeah,
Yeah.
it's allowed. Allowed.
Okay,
It's
okay.
allowed. Can you see the screen?
Yes, yes, we can see it.
Okay, so we are going to be doing robotics, and the kit that we are going to be using is a Woodblocks robotics kit. Okay, but before we start on to what is robotics and all the jazz around what are the parts and stuff like that, I have a few questions. So I'll show you a few images, all of you all, and you all tell me whether the image shown or the thing shown is it a robot or not. Okay, I have three images for you all before we start, and here is image number one. What do you think? Is this a robot? Yes or no?
No.
Uh, okay, I can hear one no. What about the rest? Are you all in consensus, or is it like somehow opposing views? And it's okay, like there is no marking or something going on for your answers. So go ahead and answer it. Do you think this is a robot? Yes or no?
Yes.
Okay, I can hear one yes. Okay, so when I ask this question, generally, children especially, what they do, they neatly differentiate between the person who's wearing the suit. So this is an Iron Man suit. So they neatly differentiate between the person who's wearing the suit and the suit, and they say that, sir, suit is robot maybe, but person is not robot. So around that is the right answer of this. What do you think about this? Is this a robot? Yes or no? This is again from a movie, Transformers. Is this a robot?
Yes.
Okay. What about the rest? Okay. So this one everyone is agreeing. Probably because it looks like a robot, I guess. Okay. So yeah, this one is a robot. What about this?
No.
What about the rest? I can hear one no. What about the rest? Okay, I couldn't hear that. So this one and this one especially, people get confused a lot, because many people identify this as machines, and machines in their mind are not robot. So like one differentiation or one key thing I wanted to highlight here is, generally, if you have a Venn diagram, and if there is a Venn diagram and there's a circle for machines, there's a shape for machines, robot would fall under that only. Okay, so it's like robot is a subcategory of machines only. And although there are some subtle differences, that's not actually the separation between machine and robot is very thin, and this is what we are going to find out from the definition. Okay, so a robot is basically, it's defined this way: a robot is any automatically or manually operated machine, again machine being the keyword here, that replaces human effort. So it's not necessary that it be automatic or it be manually operated only, like either or either is fine, but important thing is it should replace human efforts. Okay, so and one more important thing, and this is generally kind of the thing in movies where they show a lot of human like robots or humanoids as we call it. But the thing to understand is a robot doesn't need to look like a human in order to be called a robot. In order to be called a robot. Okay. So in fact, I think MIT, I guess Boston Dynamics is doing good work on this, where they are making prototypes of a robot which is looking like a dog or a pet, right? And that is also a robot. Okay. So now, as you say, now as it is said, it doesn't need to look like a human. So that's one thing. It can be automatic or manually operated. And last but not the least, it should replace human effort. That's the key word when we say what is a robot. Okay. So for example, Wally and this thing, his partner also, they were shown as robots. Okay. So now, if if you want to build now any robotics projects or any robotic ideas, okay, what are the basic building blocks that you need to know and you need to be familiar with in order to get started with robotics? Okay, that is a question that I'm answering next. So there are four basic things that we need in order to get started with robotics. Okay, and these are the four building blocks. Okay, so power is one, input is one, control is one, and output is one. Okay, so these are the four building blocks that we need in order to get started with robotics. Okay, now the power is the one with the little asterisk mark, just like mutual funds are subject to market risk while asterisk. Power needs a power source. Okay, where power source will give it the ability to work. Input. So I'll take an analogy and I'll ask you all what do you all think about each of these. Okay, so if human body were an example, and human body is a good example of what all things are needed to make a good robot. Okay, so if human body is the example, then what is power in the human body? What gives us power?
Teachers, you can answer in the chat also, or you can unmute yourself and speak. Anything is okay, but just answer so that we know whether
Yeah.
you're following or not.
Correct. And for chat answers, I'll just I need to, I guess, stop sharing 1 second. Acha. So any answers in the chat? What do you think, according to human, for a human, for us humans, what is power for us?
Food we eat.
Yes, food is a power and the source of energy for us. What about inputs? Inputs is actually very interesting. What is inputs? What are inputs for us? Any examples or any ideas for us? So if you don't know, you can say, so we don't know, please. Seeing, okay. Namrata ma'am is saying seeing. So yeah, so seeing is in fact one thing of the entire set of sensory organs. Okay, so we have five primary sensory organs: eyes, ears, nose, tongue, and touch. Okay, we have those five primary organs, and in fact, it's not much appreciated because we end up using them just like any other living being does. But that, or these organs, they provide us vital information of how the surrounding or the environment is. Okay, and nowadays it's not as necessary because we live in safe spaces. But earlier times, especially when olden times in the stone age and all, then there it was necessary to have all this sensory information, because that was the thing which helped save us from other threats. Eyes, ears. So if you heard like a very loud sound, elephants going, so you'll not go in that road to in order to avoid getting crushed. Or if you heard a tiger sound, so you try to go away from that area, right? So these are the things which give us idea about the outside world, what is in the outside world, and to take the information in. What about outputs? Any output examples in our body? Right now we are using some of them, but I hope
Work we do.
Whatever work
work
we
we
are
do.
doing.
So hand and legs generally we use, right? So typing ke liye we use hands. We move around with our legs, stuff like that. In fact, one more subtle this thing is we use face gestures. Right now I'm saying something and you are nodding, yes, 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 or sir, what is this going on at 11 a.m. in the morning, something like that. So you're giving out gestures, right? So that is output. So those are forms of output. And last but not the least, control. What is an example of control in our body?
Which things we have to do, which things we have to not do. That is the control actually.
And what help? Okay, what helps us take that decision? Which thing to do? So
Brain.
to get,
Decision
yes,
also, yes.
correct, brain, and in fact spinal cord as well to some extent, because that helps us take decisions and do, decide on which things should be done and not to be done. Okay, so this is how. So we also can be visualized in terms of a robotic system. So power is food, input are the sensory organs, output are our limbs and our gestures, and control is the brain and the spinal cord. Okay, now this, when it comes together, so now if you understand this, okay, so these are the building blocks, and in alone they are not very useful, but when they come together is when we are able to, our own bodies are a good example of that, that we are able to achieve something that can actually do a lot of things, right? And this is the same with robotics, where we can combine many of these things together to build whatever application that we want. Okay, so now in terms of a computer system also, some of these examples do hold up. So the same analogy of power, input, control, and output holds up in case of a computer also. How it holds up, let me quickly show you. So we are using computers right now, computers or a smaller computer, which is a phone. Okay, so that is something we are using right now, and the same analogy can be applied there. Okay, where power is the SMPS, input are the keyboards and whatever is giving information to the computer. Control is the CPU or the main chip, and outputs are the displays and speakers and printers, stuff like that. Okay, so now if we are going to make things using our own this thing, we need parts to get started, right? So in bit blocks, the way we have divided these parts, so the electronic parts are divided along the same lines. Okay, the same
Abhishek,
category lines.
just 1 minute. The screen is appearing a bit black. Are you seeing something on the screen? Because we are seeing a black. And uh,
Acha, 1 second.
are you sharing your
uh,
slides?
yes, yes, I am sharing.
Okay, okay. Can you please share it again?
Yes, yes, 1 second. Thanks for bringing it up. Okay. um, Now can you see?
Yes, now it's okay. Yeah.
Okay, thank you so much. So what I was saying is, so these four building blocks. So in bit blocks, the electronic parts also we have divided it along the same building blocks: power, input, control, and output. And along with the electronic parts, so just like we don't have just the nervous system in our body. Okay, so nervous system is used for sending signals and all in different parts of the body. We also have bones and muscles, right? And bones and muscles make up our body structure. Okay, the same way, along with the electronics in our robotic kit, we have parts to create the bones and muscles, so to speak, which will help us create the robotic structure. Okay, so now let's look at the parts one by one, and simultaneously we'll have a look at the parts also, how they work. So first thing, what we are going to use, we are going to make use of the power blocks. Okay, so power is the most primary blocks in bit blocks, because one, it gets the energy from the power source, and two, it gives the energy to all the other blocks that are connected to it. Okay, and the best part about the parts in bit blocks, electronic parts especially, the name is written on the parts. So right now, if you see the image, this PPT image, as well as the power blocks that I'm holding, power is written on the blocks. The name power is written on the blocks, and this is true for all the electronic parts. Whatever their work is, the name is written on them. So even if you forget, you don't need to remember it or something. The name can always be referred. Okay, now as I mentioned, power needs a power source to work. Okay, so if power source is required, what do you think would be a power source for our circuit to work? Anybody? What do you think could be the power source for our power blocks to work? And it's okay if you're wrong.
Battery.
Yes, battery. So we have a battery that we are going to be using, and it's not any kind of battery. We are going to be very specific. We are going to use a 9-volt alkaline battery. Okay, so alkaline batteries generally tend to last longer. That's why alkaline battery, and they are environment friendly also. So 9-volt alkaline batteries are what we are going to use, and this is going to be the power source. Like we said, na, power as a asterisk. Power source is needed. Okay, so this is our power source, and when I connect the battery to the power source, here is what will happen. Okay, So I connect it like this. Okay, and as soon as I push the power button, I should be able to see light. Can I see that? Yes, no, maybe. And I cannot see the chat messages, so audio response will be
Yes, sir.
better. Okay, so now now this light, everyone, this light is an indication that battery is getting the power and it is able to turn on the light. Okay, very simple. All right, now we are going to be making different logic combinations, and herein I want you to actually make a note. Okay, whatever we are going to be discussing, it is some form of a logic combination only, and the best part is the result of that logic combination will be visible to us. It will so basically we have these kind of blocks. So one analogy comes up in my head is of scratch, where we join different things together. Scratch coding, if some people have tried it. So there we join the blocks digitally and they follow our command. Here we will join the blocks physically, so it's kind of a physical computing, and then they will work, they'll start working. Okay, so now if you now we'll try out our first set of logics, and for trying out our first set of logic, we'll need output blocks. Okay, so one thing I want you to make note of before we go ahead, one thing I want you to make note of: the power blocks is red in color. Okay, and the outputs which are visible to you on the screen, they are black in color. So we have three different outputs in our kit. We have the lamp, we have the buzzer, and we have the motor. Okay, so first logic combination naturally is going to be power plus output. Okay, the first logic combination that we are going to try out is the power plus output. So we are going to take the power and join it with the outputs. Okay, so the logic combination of power and output looks something like this. Okay, so I don't have a lamp right now, I'm so sorry, but I can definitely try a power plus buzzer output. Okay, so if you observe, okay, right now I'll just turn off the power. Okay, so it's as simple as joining two blocks together. Okay, it's as simple as joining two blocks together. So when I join the power and the buzzer, okay, I just snap them together, and when I turn on the power now, okay, the sound output is coming, as you can hear. Okay, and the sound energy is given as output. Okay, that is why buzzer is known as output blocks, because it takes in energy and gives out sound energy. Okay, it takes in electrical energy and gives out sound energy. Okay, is this clear to you all, the power and buzzer example? Yes, no?
Yes, sir.
Yes,
Okay,
sir.
so same way. So again, power plus buzzer is a example of power plus output logic. Okay, so now same logic in this series, it can be a power and motor. Okay, so light, sound, and motion generally are things which attract the kids the most. Okay, they love to see things giving out light, giving out sound, and stuff like that. Okay, now before we go to the motor, one thing I wanted to show you. Okay, so now this is a physics thing and the physics trivia. So if we connect the power to the buzzer, okay, and I turn it on, it is giving out sound in a kind of irritating way. Okay, it is giving out maximum sound. Now tell me what will happen. Okay, so if you observe the sound blocks carefully, there is a small hole at the top of the buzzer. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now tell me what will happen if we cover the hole which is there on the buzzer and we turn on the power. What will happen if I cover this hole on the buzzer and I turn on the power? What will happen? Anything different?
Sound will not blow.
Sound will not come. Yes. In fact, it's the analogy to this is, I'll show you the working first. So if you see, the sound is very muted. Okay. In fact, if I think you can hear it also, I have held it close to the mic. Okay. When I cover it, its intensity is dropped. When I leave it, it's coming out maximum. Okay, so and why this is happening, does anybody have a clue?
Speaker is there.
Okay, because of which what is
Small
happening?
speaker may be added.
Yes, and because of that,
Sound is not coming if we are covering that.
correct. So in physics, the this principle is explained really well. that sound needs a medium to travel, and in our case air is a medium. The air which is around me is a medium for sound, and because I'm blocking the air, because I'm blocking the medium air, the thing which happens is the sound doesn't get placed to travel outside, so that is why the sound intensity drops. Okay, hand is another medium because of which I'm blocking the air medium. Okay, so same way, if I make it half, if I cover it half, it will give me half intensity. Okay, so depending on how much I cover, the intensity will change. Okay, so now we can go to the motor one, and motor one is also pretty interesting because motor or moving things is something children that also love to see. Okay, so just give me a second. Okay, so I have taken the motor blocks, and in the motor blocks the thing to understand is, okay, motor mein there is a motor driver, the one which drives the motor circuit, and there's a motor. Two things in the motor driver. Okay, now the motor, if you see, it has this white color shaft, and when I connect this to power, okay, it will start moving. Okay, so now I have connected this to power, and I'm just holding it in my other hand. See how the shaft is rotating when I turn on the power. Can you see that?
Yes, sir.
Okay, so this is the motor driver blocks, and when I'm when I turn on the power, it is moving. Okay, and just like this one, just like power and motor is making the motor rotate, I can, so right now motor is rotating in one direction. Okay, so I don't know whether it's forward or not. So right now it is rotating in one direction, but as soon as if I want to make it go in the opposite direction, then on the motor driver I have a switch with which I can make it go in the opposite direction. So if earlier the motor is rotating from left to right, I can make it go from right to left also. Can you see that? So this switch which is there, I'm rotating it. Sorry, I'm pushing it in the other direction to make it work.
Yes.
Okay, so changing direction is very easy. Okay, and just like in real life cars, we can also make our cars go forward or backward. Okay, so now we know how the motor works. Okay, so we have tried out power buzzer and we have tried out power motor. Now if I tell you that ma'am, you need to make an output work, okay, any output, power buzzer or power motor, but you cannot use the battery as the source. You cannot use the battery as a source. How would you make the experiment work? You cannot use the battery as a source. Then what would you do, ma'am? Any idea? And it can be wrong answers also. Like again, I am not giving you marks for this training session, so it can wrong answers are also welcome. What would you do? So let's say you want to make the buzzer work. If you want to make the buzzer work, but you cannot use the battery, what would you do?
It cannot work.
Sure, confirm.
Without battery, how it works?
Okay. So ma'am is saying that without battery it will not work. How many agree with ma'am? How many have a counter? He's saying no, no, ma'am. Without battery also it will work. Anyone has a counter? Anyone? Anyone in the opposing party? No, ma'am. It will work without battery also. No one? Okay. I think that's a very confident response. Okay, ma'am will be right only. Okay. Okay, so let me try to answer that. But before I try to answer that question and show you the answer also, let me use an analogy. Okay, what other, if electricity is not available, what other sources can you use to get work done? Okay, if electricity is not available or fuel is not available, what other sources can you use in order to get things done? And you do this a lot. Okay,
UPS,
so
Sun,
UPS generator.
yes, generator is one. So whenever electricity is not there, we have generator at our home, which will give the power when electricity is not there. But What about other this thing? Let's say generator also ends. Generator also is finished. Power from generator is finished. Then what? So let's say, huh?
Hello?
Yes,
Sunlight.
sunlight. Yes. Now we are thinking.
Yes.
So essentially, what we are doing. So now we are using a non-electrical source to. So solar is one, I think, example that sunlight say we can generate. Do something. Okay. Unfortunately, in the box that we are having in our school, the solar this thing is not there. We do have a solar blocks. In we make solar blocks, but we don't have solar blocks in our kit. So थोड़ा सा limitation हो गया. Then what will do? Solar is one good answer. What else can we do?
Windmill.
Windmill also, yes. Windmill may will yes. Windmill may, what is the principle? Can you tell me what is the principle of windmill? Like how it works? I wanted to know. No idea. So windmill may what happens? Windmill may the energy is like the blades are rotated and that creates the energy to do something. Like in England and all, they use it for turning the wheat grains into flour. So that is one action that they do. Okay. But the thing that I am talking about, it's close to a windmill only. So if you think about this task, okay, let's say you want to take water out from a well. You want to draw water out from a well, okay, and you don't have pump. Sorry, pump is not working because electricity or diesel is not there. How would you take out the water from the well? Did you understand the question? Did everybody understand the question? Yes, no?
Yes, sir. Yes, sir.
So now can you tell me how will you take out water from the well? It's very simple question.
Using
Huh.
using one rope, we can put one
Yes,
pot in that and
correct.
pulling it.
Yes, exactly. And pulling it out, we use our own energy, right, to take the water out,
Yes, yes,
right? So can't we use our own energy to drive a circuit? Meaning to say that if I connect something like this, okay, just a second. Okay, so let's say I have a circuit combination like this. So here I've connected power, motor, and buzzer. And what
yes.
I've done, I've connected a big wheel, but it's not necessary that you use the same wheel. Even small wheel is okay. Okay. So now, right now, I don't have a battery. Can you see? I don't have a battery in power. So battery is removed. Okay. But still, when I rotate the thing, see what happens. Okay. Rotate the wheel, see what happens. I'll try to take it closer to the mic. Can you hear? Can you hear the sound?
Yes, yes,
Yes, sir.
Okay. So what is happening? Now can I say that I can use my energy to drive the circuit?
Yes.
yes.
Okay. So what is happening here essentially? Basically, we are not creating energy. Okay. So I am not some energy creator that I can create and supply, but I am converting my energy into the electrical energy which is needed for the circuit. Okay, so circuit also doesn't have its own energy. Circuit takes it from the battery which is the source. But right now, because battery is not there, I am giving my energy as a source. So mechanical energy is going into electrical energy to whatever output. So sound energy is there, so it will come as sound. So mechanical to sound energy. Okay, if it was light was there, so mechanical to light. Okay, so now same way in the batteries also there is one form of energy. Please research about it. In batteries also there are some chemicals which are there in the battery. So chemical energy is created in the battery, which in turn creates electrical energy for the circuits. So because of that chemicals, the battery is able to run the circuit. Okay, again energy conversion is happening. Energy cannot be created or destroyed. Okay, so that is the thing I wanted to remember. We are just converting it from one form to the other. Okay, clear to everybody?
Yes, sir.
Yes, no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now let's move on with the logic combination. So we have tried out the logic combination of power plus output. And can you see the screen?
It is coming black, Abhishek. You can maybe share it again.
Yes,
Acha.
sir.
That's why I verified.
Okay.
1 second. Okay. Yeah. Is it visible now?
Yes, yes, yeah.
Okay. So now let's move on to the next level of this thing. So we are actually we did the coding of power plus output. Okay. So we saw that what happens when we connect power and output together. We see that the things are working. Okay. Now if we want to make smart things, okay, we are smart, right? Everybody of us is smart. Yes or no?
Yes.
Yes, we are smart,
Yes.
right?
Yes.
So
Yes.
now we'll make circuits also that are smart. Okay. And how do we make circuits smart? We make them smart by adding an input. Okay. Now adding an input means we are adding a sensor based on whose input the circuit or the output will work. Okay. So now I have two sensors that I'm going to show to you today. One is a dark sensor and one is a distance plus IR sensor. We'll go to that one by one, and then we'll see the working also. In fact, we even have a button sensor also. Button also I'll try to show how it works. Okay. So the way these sensors work, okay, the logic combination, the idea of this thing that is to be understood is that earlier when we tried power output, power plus output logic, output worked directly whenever we turned on the power. This time, however, the logic combination that we are going to try is power, input, and then output. Okay. So now this time, input blocks, which are dark blue in color, please note, will come in between power, which is red in color, and output, which is black in color. Okay. And there's a reason it is in between. So it is something like an if else statement. So if sensor is on, output will be on, else the output will be off. ठीक है. So if में if condition लिखना होता है तो कभी भी if condition पहले लिखते हैं, right? उसका output लिखने से पहले in coding. So same way in this also the sensor is first, the output will come second. Okay. So now if you want to make the logic of let's say we want to make a buzzer which works only in dark or darkness as we call it. Okay. Then what we will do, then we will connect the power and dark, okay, and the dark and buzzer. Okay. Something like this is what we'll connect. And this time I'll again get the power battery back. So now no restriction of using the battery. And the dark sensor, as the name is mentioned, is for sensing darkness. The dark sensor, as the name mentioned, is for sensing darkness. And now see what happens. So earlier when I did the power and buzzer, it was giving sound directly. Now see what happens when I connected this way. Okay. Can you see the power light is on? Yes? No?
Yes.
Okay.
Yes, sir.
So now what is happening this time? So power this thing, although power is on, the buzzer power is on here. So till even then the buzzer is not working. Okay. And this is because the dark sensor is asking for an input. Is it dark around? It's question. It's asking a question. Is it dark around? And now you tell me. Is it dark around me right now?
No.
Okay. So now if I create darkness, either artificially or turning the lights off around me. Okay. So let's say I cover it artificially. Is it making sound?
Yes.
Okay. So whenever I'm covering the dark sensor, okay, specifically the LDR part, okay, there's a LDR part and it's in the image also. The LDR part of the dark sensor is what we cover in order to make the output work. Now LDR, what do I mean by LDR? Does anybody know what is LDR? Anyone?
Light dependent register.
Yes, light dependent register. So what happens? So LDR is a special type of a register whose signal or whose resistance changes depending on the light. So if light is there, it will give one signal. If light is not there, it will give another signal. Okay. And so here we can see that if we cover the dark sensor, it is making the output work. Okay. Same way, if I take it under the table also, it will work. Okay. Because we are creating the darkness and it is making the output work. Okay, did you understand the dark sensor? Yes, no, maybe.
Yes.
Yes.
Okay, so now if you want to make a darkness control car, okay, then also we can make it. The logic will be power, dark, and motor. Okay, so I'm not showing it right now, but the logic combination will remain similar. Okay, now one question should come to your mind. Okay, and this I'll not answer it right away, but this question should come, sir, if this is dark sensor and if I want to sense light, okay, this is dark sensor you showed me, and it is working in darkness, but sir, what should I do if I want to detect light instead of darkness? Okay, that is a question which is naturally coming, no, that if I want to check light in the circuit, then what should I do? Any idea? Yes, no, maybe. Any idea how we can check light also?
No, no idea.
Acha, not a problem. So, yeah, thanks for the response. But what you need to understand that right now it is sensing darkness. If you want to if you want to make it sense light, we need to do something opposite. Okay, and we are going to do that very soon. But first, now let's go to the this thing. One more part of the dark sensor. In the dark sensor, now I told you that this is the sensor, which is the LDR. Okay, so when I'm covering it, it is giving buzzer sound. Okay, but there is one more thing on the dark sensor, which is this dial. Okay, now dial is kind of how the dark sensor, how we can set the dark sensor to respond at a particular level. Okay, so this dial we can turn, it's like our eyelids. Okay, this dial is like our eyelids, so it determines at what level of this thing the sensor should respond, at what level of darkness. Okay, so for example, if I want to respond on more darkness, so I'll make it little bit to the right, and there's an arrow. Okay, okay, if I want to make it, so it is a sensitivity control. Okay, if I make it to the left, it will be less sensitive. Okay, how much ever I try to cover, it will not work. Okay, so it has to be just right in order to get a response. Okay, and many times student will do this, they'll just rotate the dial. Whenever you tell to make a sensor circuit, they'll rotate the dial and say, ma'am, output came, output came, output came. So here you have to correct them. Dial is not how you get the output. Dial is something you keep at one position and based on the sensor principle. So if it is a dark sensor, you cover it. If it distance sensor, then you do something else, but that sensor has to be triggered in order for it to work. The dial should not be rotated. So dial is just for adjustment, not for making it work. Okay, so sometimes when it doesn't work, you can adjust, but dial is not for making it work. Okay, understood everybody, the dial and the sensing part of it? Yes, no, any doubts?
But how can we detect light? That question.
Which one? The LDR?
Yes.
Okay. Yeah, thanks for asking. So what happens, ma'am? So this LDR, no, which is there, I'll turn it off. This LDR is there, right? So it is having a light sensitive material. Okay, very simply, it is having a light sensitive material. Like there are some plants, na, in the nature which are there. When we touch them, they close. Have you seen those? I don't know what it's called in Marathi or Hindi. In English, we call it mimosa plant. Okay, so that's kind of an input we give and the plant closes off, right? Same way, so that is a touch sensitive plant. This is a light sensitive material. Okay, basically on light, whenever light falls on it, there's an electronic this thing which happens. So electrons are shifting to another level. So because of that, the light intensity is detected. So whenever light falls on it, it will give one signal. Whenever light doesn't fall on it, it will give another signal. So change in light intensity can be sensed by this sensor. That is why this material rather. Okay, this is a light sensitive material, and changes in light, okay, whatever light changes are there, it can be sensed by it. Understood?
Yes, sir.
Okay, so others also, please ask me, please stop me if you have any doubts. Otherwise I'll move ahead. Okay, so now we'll go on to the next one, which is the distance sensor. Okay, and distance sensor, so let's say if I want to make a doorbell which is contactless. Okay, I want to make a doorbell which is contactless. Distance sensor is one of my favorite sensors, actually speaking, because distance sensor is sort of unique. First of all, it has two parts. Okay, unlike the other sensor. Other sensor just have one. Okay, distance sensor has two parts, and in this, distance is the brain, IR is the eyes. Okay, distance is the brain and IR is the eyes. And now how it works? It works by detecting objects. Okay, this sensor, it detects objects. So whenever something is brought in front of it, it will give yes, and whenever something is not there, it will say no. Understood? Yes, no? You didn't understand, please tell me.
Yes, sir.
Okay, so now I'm going to make a contactless doorbell using this circuit. Okay, so what I'm going to do, I'm going to connect power. I'm going to make this circuit. Okay, sorry, the third one, power, distance, and buzzer. That is the logic combination that I'm going to create. And again, please note, the logic combination is still power, input, and output only. Okay, so there is not much change in the logic combination. Okay, can you see that? The power, distance, and buzzer. Can you see that?
Yes.
Okay, so now you will now observe what is happening when I get an object in front of it. So normally when I turn it on, it is not giving me any signal, but as soon as I get something in front of the IR, when it is not there, it's not doing anything. When I get my hand, it is sensing the object. Are you understanding? Yes, no?
Yes, yes, sir.
Yes.
Okay, so this is how the distance sensor works. When you get the object near it, it will give a signal. When the object is not there near it, it will not give a signal. Okay, and same way, so this is a contactless doorbell example, but you can easily make a contactless torch or a car which works in a contactless manner. Okay, so with this, actually you can make a car which is like a follow me car or a pet car. Okay, so when you show your hand, the car will follow your hand, and when you don't show your hand, it will stop. Okay, so that is one application that you can do. Same way, you can also make a car with the distance sensor, which will go away also. Okay, so when you show your hand, so it's like it is scared of us. Okay, follow me not, or touch me not. Okay, in that, the car will not follow, so car will go away from our hand. So when we get our hand, it will go away, and when the hand is not there, it will stop. Okay, two application, follow me and touch me not. Okay, follow me may the car follows our hand, and touch me not may the car goes away from our hand. Okay, but both may the logic is power, distance, and motor only. Did you get it? Yes, no?
Yes.
Yes, sir.
Okay,
Yes.
so now now nobody asked me, sir, you show this distance and IR, but you didn't tell us how this works. Like in LDR, the principle you explained, but in this thing you didn't explain. Nobody asked me, so shall I skip that?
No, sir. Please explain it.
Okay. So so how how this distance and IR sensor detects objects, let us get to know. Distance and IR is kind of interesting. Okay, and I'll have some questions, so everybody please pay attention to this sensor. Distance and IR, so there are two parts, there's a distance and there's a IR. Now we already know that distance, I told that it is the brain, it is like the brain, it is receiving the signal, and IR is like the eyes. So IR is seeing the object. Okay, so now for seeing the object, if now we saw, right, that IR is seeing the object. Okay, now how is it seeing the object? Okay, let's understand that. There are two light like things, LED like things as we can call it, on the IR. One is transparent, one is black in color. Can you see that? Yes,
Yeah.
no?
Yes, sir.
Okay, so
Yes, sir.
there are two lights, okay, transparent and black, and they both of them are used to understand if there is an object. Transparent one emits light, black color one receives light. Okay, and they work on IR light, okay, infrared light, which will come to shortly. So what happens at its basic, transparent one throws out the light, and it gets reflected, it gets hit on the object. When the object is hit with the infrared light, after that it reflects back, because light can reflect, and the light reflects and gets back on the IR black LED. Okay, so transparent one is called transmitter, and black one is called receiver. Okay, so light from the transmitter goes and hits the object, and then it comes back on the receiver, and then it is understood that okay, so if the light is received back, okay, the light from the transmitter going, hitting the object and coming back, if the light is received back, then the circuit, like circuit generates a signal, okay, there is something in front of me. Make sense? Yes, no? Hello?
Yes. Yes,
Okay.
sir.
Okay. So that is how. So transparent one emits light, black one receives the light, and based on the light reflection, it detects. Okay. Now I mentioned that infrared light is used. Has anybody heard of infrared light concept or IR light concept? Don't worry,
Yes,
if
sir.
you say yes, I'll not punish you. Okay. IR
Hmm.
light, and
Yes,
is it
sir.
something that you can see? Can we see infrared light? Are we able to see infrared light? Yes, no,
No, sir.
maybe we don't know.
No,
No.
sir.
And so we cannot see. Okay. Why is it we cannot see? Can so if anyone knows the reason, please say yes. If anyone doesn't, then please say no. I'll explain. Do you know why we cannot see infrared light?
No, no
Okay.
idea, but we can't say that.
All right. So the no part that we cannot see, that answer is correct. But now let's understand quickly what infrared light is. So rainbow, everybody knows, right? Everybody knows rainbows.
Yes.
Okay.
Yes.
Rainbow mein how many colors are there?
7.
7. What are they? Any now any idea about
With
the
joy.
colors? With your right?
Yes, with
Violet,
joy.
indigo, blue, green, yellow, orange, red. Okay.
Yes.
So from violet to red, and coincidentally,
Violet.
okay, we also call it the visible range or visible light. Okay, from violet to red, whatever colors are there or whatever light is there. So colors are essentially light. Okay, so it's not like colors are red and stuff like that. Violet to red is also our visible range. So beyond violet we cannot see, beyond red we cannot see. Okay, so the light which is beyond violet, and this is seen a lot in fairness creams ad and beauty ads, UV protection, right? That is called as ultraviolet. So beyond violet, ultraviolet, and something which is beyond red color is called as infrared. Okay, beyond violet is ultraviolet, beyond red is infrared. Okay, so now the second question is infrared. If we cannot see with our naked eyes, is there any technique with which we can see with our eyes? Can we do some technique to see it? Yes, no, I
I
don't. We
think,
don't know.
yes, sir. The prism, something is there.
Not
I
prism.
don't know.
Not prism. Thank you for answering. Not prism. But in fact, if you saw me doing the experiment, I don't know like how many saw it well. I'll stop sharing the screen for this. Okay, so same logic. So same logic. If I want to, see the light coming from the infrared. So right now I cannot see. Okay, but when I turn on the power, okay, so then also it's not very properly visible. But if you see the, can you see it? Can you see my camera reflection?
Yes.
Yes.
Yes, sir.
Okay, so it is, in fact, it is visible on a camera. Okay, so if you hold a phone camera or a this camera, web camera, it is visible. But if you ask me whether I can see it or not, no, nothing is visible. Okay, on the camera reflection I can see it. Okay, so light is being thrown and then it is being received.
Glass something.
Yeah, so camera is the thing
Glass
which is
little.
needed. Correct. So
Night
that is
vision goggles are so there. Also.
yes. So, but I think night vision, I'm not sure exactly if they are able to see IR, but basically there are some special equipment like camera also. It can capture visible light and its lens is wide enough to capture light outside the visible spectrum also. So mobile camera is a very easy way. Okay, mobile camera or web camera. Okay, so this is how. Okay, so we can see the light coming from IR. Okay. Now other application of the IR sensor include it being a flame sensor. So if you want to check flames, flames can be also detected using this same sensor. Why? Because in fire, some part of it we can see directly, but in the fire, the outer ring of it, especially, it has in IR, infrared light. Okay. So if you study about the physics of flames, flames also have an outer layer of infrared, because of which this IR can detect flames also. So it is a flame sensor also. One more thing that it can be used for, this can be used for color detection. Okay, this sensor can be used for indirect color detection. Okay, so there are some applications or there are some activities also where, so for example, there's an activity called as line follower robot. Have you heard of this robot, line follower robot?
Yes, sir.
So in Amazon and all these days, many times they use less humans and more robots which can follow a particular path. Okay, and the path following robot, okay, is what we call as line following robot. Essentially, this sensor, the distance and IR sensor, is used to detect a line, and that line, so maybe it is black color line for example, and then it keeps on following that line unless the code tells it to stop. Okay, so this sensor can also be used to make a line follower robot or a path follower robot. Okay, so we are not going to do that today, but maybe one of the activities that I want you to try out is a line follower robot. Okay, get it?
Yes, sir.
Okay. So now let's move on to the next part. So we have two parts left in electronics. I hope you all have some time, right? We have two parts left. Just after that, we can conclude this session. So one part out of that is the invert. One part from that is the invert. Now, what does invert do? Let me explain very simply. Invert is like a friend of the sensor. Invert, and it can be purple color also. Okay, it's fine. Invert is a friend of the sensor. Now, friend means what? Okay, like normally we think na, if friend means whatever we like, they also have to like, or whatever we don't like, they cannot like, right? Invert is kind of weird. Okay, invert is a friend of the sensor. Still, it it does the opposite of whatever the sensor says. Okay, so if sensor says yes, invert says no, and when sensor is saying no, invert says yes. Okay, so it does opposite of what the sensor says. Okay, so I asked you this question right a few minutes back. If you want to detect light with the dark sensor, if you want to detect light with the dark sensor, how is it possible? So it is possible by using invert. Okay, so when you use invert, here is a circuit that we will make. So the logic combination this time, so we have seen two logic combinations: power output, power sensor output. Two logic combination we have seen, where in first one output directly worked, second one output worked with a sensor. Now the third logic that we are going to see is power sensor or power input, control and output. Okay, so invert is an example of control blocks. Okay, invert is an example of control blocks. Now can everybody see my screen, my camera? Are everybody able to see my camera?
Yes.
Okay, in this,
Yes,
what is
sir.
the logic that I have made? Power, sensor, invert and output. Okay, power, dark sensor, invert and output. So powers, input, control and output. Okay, and here I want you to see what is the difference as compared to a normal power, dark and buzzer circuit. Okay, when I turn it on, it starts buzzing automatically. Okay, until and unless I cover it, it keeps on buzzing. Okay, just a second. So it is basically I have the tube light in front of me na? That is why it is little bit less sensitive, but can you see that when I'm covering it, so sorry,
Mhm.
when I'm covering it, it is not working. When I'm not covering it, it is working. Okay, so it
Yes,
is
sir.
working in the opposite manner. So what it is doing, instead of making the dark sensor work in darkness, it is making it detect light. Okay, and that's all because of the invert. Okay, so because we have used invert, okay, dark sensor plus invert, it is doing the opposite. Okay, so it is detecting light. So can this circuit be used in a morning alarm circuit? Can we use
Yes.
this circuit in a morning alarm circuit?
Yes,
Yes.
sir.
Yes, sir.
Okay. Where will you keep it? Will you keep it inside the home or will you keep outside your window? Where will you keep it?
Outside only.
Window.
What, ma'am?
In window.
In window.
Alarm.
Okay. Why window? Because light comes from there only, na. So if we want to make this as alarm for morning alarm, so then it needs to be kept outside the window only. Okay. So this is a circuit using invert, and okay. So now this is a circuit using invert. Now I have one challenge for you, and this I want you to do when you go to the school. Okay. So the challenge for you is, okay, this is a Whitlock's badge. This is a Whitlock's badge that is there in each and every kit that we give. Okay.
Mhm.
So now your task is, and I'm not going to tell the answer to that. Your task is to protect this badge. Okay. So think of it like this is your badge of honor. Okay. Think of this as your badge of honor. Okay. And this you have to protect from getting stolen. Okay. This badge you have to protect from getting stolen. Does it make sense?
Yes.
Okay, so
Yes.
that is your task, that you need to find out how to protect it. Okay, will you find it out for me? Yes,
Yes.
Yes,
no?
sir.
Okay, so find it out and tell me the answer. Okay, what will happen uh, with respect to the badge? Okay, now last but not the least, I have one electronic part which is left, which is the wire tab. Okay, can you see the wire tab? Yes, can you
Mm.
see the wire tab? Yes, no, maybe.
Yes.
Okay,
Yes.
so now
Wire tab.
so power is red in color. Based on the coloration we'll discuss. Power is red in color, sensor is dark blue, invert can be yellow or purple,
Mm.
and wire tap is which color? First of all, tell me that.
Red.
Red. So which part do you think it is related to?
Power.
Power.
Yes,
Track something.
yes, power. So basically power and wire tap are from the same family. So again, wire tap also is related to power only, but wire tap doesn't do the work of giving power. It does the work of power transfer.
Okay.
Wire tap does the work of power transfer. So what happens? So we all know extension boards, right? So basically
Mm.
this is a mini extension board in our circuit. So whenever we want to carry the energy from one part of the circuit, we want to carry it to the other. Okay, so that is when we make use of the wire tap, and that can be used to transfer the power from one part to the other part. Okay, so that is used for power transfer. Let me show you an example. So if I connect power to one wire tap, if I connect power to one wire tap, and to the other wire tap I want you to connect buzzer. Let's say you can connect anything, but I'm connecting buzzer. Okay, can you see that?
Yes.
And right now if you see, these circuits are not close to each other, they are separated. Okay, only there's this wire is there, this 3-pin wire is there, which is connected between the two wire taps. Okay, now when you connect it and when I turn it on,
Yes.
can you see, can you hear the sound?
Yes, sir.
Yes.
Okay, so basically wire tap is doing the work of power transfer. And one last thing I wanted to observe, and this is important for the wire tap. Okay, wire tap may tell me, so there are two wire taps. Okay, one there, I have two wire taps with me. I used two wire taps just before this, and the the wire which is connecting, can you tell me how it's connected? Is it connected same or it is connected opposite?
Opposite.
Opposite. Yes,
Everybody
opposite.
can see that, right? So in wire tap it is important to do opposite connection. So there are
Opposite.
two connectors on the wire tap. Okay, if somebody is making notes, please make notes. Okay, in wire tap there are two connectors. One is a standing connector, as you can see in the bottom, and it's called as B. I think the name is also written here. And another connector is A. So A of one connector goes into the B of another connector. Okay,
Mm.
A of one connector goes into the B of another connector, and vice versa. Okay, A to A will not work and B to B will not work. Okay, so just to show you a quick example, I'll try to connect B to B. Okay, just a second, I'll connect B to B, and B to B will not work is something we'll prove right now. Okay, and you also be careful, students a lot of time they mix it up. Okay, and then they say ma'am it's not working. Okay, Y tab. Okay, Y tab right now I have connected B to B. Can you see? And not
Yes.
business to business wala. This is B2B connection. Okay, so now see what happens when I connect the power on one and the buzzer I connect on the other. So like the before only I make this circuit, but now see what happens. Okay, now tell me whether you can hear. I have turned on the power, so okay, you can see this small light. Okay, but is the sound audible? Is the sound coming?
No.
No.
Yes, and that is because the connection is same, B to B. Okay, same thing will happen in A to A. So A to A also will not work. Got it? Okay.
Yes, sir.
So wiretap is that like that. Okay. All right. Now time for questions. Questions, doubts, counters. So counters means we are all adults. So if you have any counter, so if you have, sir, you said something like this, but I have seen that in real life it works something opposite. So counters are also welcome, but questions and doubts are also welcome. Any questions, any doubts to whatever we discussed?
Teachers, you can ask any questions which you have.
Yes. And I would like to see questions, because if questions are not there, it can only mean two things: everything is understood, which is good, or nothing or very less is understood, which is bad. So questions, I'd like to hear them if there are any.
Yeah, I think one thing, I think Abhishek, you have taught very nicely today, and giving all real life examples. It is because I have learned a lot in today's session, and it was very nicely explained.
Thank you, thanks a
And
lot, sir.
the teachers are not speaking because they have followed everything, not because of they have not understood.
Yes, I hope that's the case. In fact, so now I'll give you two thought experiments, teachers. So one thought experiment is, so now let's say you make the circuit, and please write it down. You can try it out and tell me. If you make the logic combination something like this, where you connect power, lamp, sensor, and buzzer, and it doesn't matter what sensor is there, dark sensor, distance sensor, button, anything. Power, lamp, sensor, buzzer. If this is the logic, then which of the output will listen to the sensor and which of the output will not listen to the sensor? Okay, that's question number one for you. Okay, I hope that's understood. Yes, no. Is the question
Can you
understood to
repeat,
everybody?
sir, again? Can you repeat that question again?
Yes. So my question was, if the logic is power, lamp, sensor, and
Sensor.
buzzer. Okay, if the logic is this, which of the output will listen to the sensor and which of the output will not listen to the sensor? Okay, that is question number one. Okay, and and this I want you to figure out practically, not just answer it verbally. Second question is, if you want to make a car, okay, again circuit only, not the not the structure wala thing. If you want to make a car which is something like this, okay, normally it will go straight. Okay, so here my question. Normally this car will go straight, but as soon as it sees this thing, it sees a obstacle like a person or something, it will take a turn. Normally straight, on seeing a person, it will take a turn. What is the logic that you will build in order for the car to work? Okay, so those are two questions that you want to answer. One is the logic that I gave, and second is, in case no one is there, car should go straight. In case someone is there, car should take a turn. Which turn, it doesn't matter, but it should take a turn. Clear with both the questions? Yes,
Yes,
no,
sir.
maybe.
Yes, yes.
Before next
Yes,
session, I want you
yes.
to find out the answer,
Yes.
and next session की starting में यही discuss करेंगे
So
कि
this is
इसके
the
answer.
homework for all of you. This is the homework
Yes,
assignment for all the teachers.
correct. So
Yes, sir.
before next time, please
Sir,
keep the answer ready. Huh. Go ahead.
Whatever you have taught now today, sir, can you have the few notes, written notes, or few printed notes of this?
Yes, yes, ma'am. What I will do is that I will share the recording.
Huh. No, actually, we have written our in short, but
Okay.
then also, if proper notes we will get, so we will work on that.
So I don't have proper notes of this session, ma'am. But like the idea, and I mean, I don't mean to have proper notes also. Rather, I think the notes should rather be whatever you have understood, because I can always give you notes, but this
The
is not a subject that we are learning. You want to practically understand it. So whatever you have heard also, please try it out and then verify
Yes,
for
but
yourself.
what
Can you share
is whatever
PPT?
you have just now shown, na,
Okay.
all
The
things we can't remember, sir, at a time, na, so only.
Acha. So do you want?
We have written, yes,
Mhm. Go ahead.
because the same things we have to teach to students also, no? So,
Okay. So I can do one thing. I can share the PPT link, so that can be a reference. But I would request, see, PPT link से क्या हो जाता है many a times that we get the habit that okay, PPT है, so we can just show the PPT and done. Try to, so my advice would be experiments आप try
practical,
करना ही है. प्लस आप पीपीटी वाइज भी
yes.
अगर आप खुद का पीपीटी बना लो, यूज द एलिमेंट फ्रॉम दिस, आई इट डजंट मैटर टू मी, but try to make your own PPT through that.
Yes,
Mhm.
sir,
That would be
definitely.
much better.
So the more you practice teachers, the better you will get at it. And
Yes.
practice is the only solution for this. You have to get your hands dirty, use the kit, and that is how you will learn more and more.
Exactly.
So now just today we got the many different ideas related to kit only, that names, because we don't know the names of that
Correct,
small
correct.
parts, but we can. So as but we will work on that, sir.
Correct. Correct. Perfect. Anyone else with any questions?
Good afternoon, sir.
Yes, good afternoon, ma'am.
Uh, Actually, sir, my question is what? We are introducing AI and robotics from standard 5 to 9. So
Okay.
first, should we introduce robotics or AI?
No, first, please introduce robotics and the working of these parts. So for example, Raj sir, as Amit sir shared like the curriculum
Yes,
link
yes,
with you.
yes, yes,
Yes,
yes,
shared, right?
yes.
So in that also, so those are activities which we have suggested, but always have that thing key introduce what the parts are first. Okay. So otherwise, what will happen? There'll be a haphazard, there'll be chaos. Ki, ma'am, what we are doing, we are not understanding. So first explain the parts. So maybe an introduction session for the electronics and the Vitrix, both can be there, and then only please proceed with the activities. Introduction is very important, and try starting with robotics first and then with AI. So I think we have kept it for grade 7 according to our curriculum, but you can introduce at a lower level also, not a problem. But the idea should be understood that how things are working. Without that, it will be very chaotic. And AI we are still left to cover. So AI, maybe
Yes.
when they have the kit, we can cover better.
Okay, when we are teaching robotics to the students, that time should it go hand on hand, or first we should have the experience and then students will follow? What should we do?
So, see, in terms of practice, I definitely think you should have like at least 2 times practice before showing it to students. But in the class, I think it's better that and this is my opinion. I think it's better if you do it along with them. So then you can also see. So many times, some teachers have this practice that they don't give the kits to students. They hold back and they show, and then they after some time they give it to students. Again, it's not wrong, but what I think is when children do these things, they can irritate sometimes, that they can create the buzzer noise and things like that. But the thing that you will understand is how much are they taking in. So when you say that power and output, are they really taking it in, or are they doing something else, like they are putting output first and then power, or are they doing some connection problems? So that is what you will get to know when children have the kit. So I prefer that kind of methodology. So I that's why I asked her also at whether you all have the kit or not, because I prefer that kind of methodology only. That you have the kit and you do it with me. That is where the joy lies. That, oh, acha, I made it. that kind of thing.
Yeah, next time we will try to do it in the school itself so that all of you can try it along with Abhishek sir. And
Yes.
uh, I think all the doubts. So we have given two problems as homework, and we have a separate group with the teachers. So you can share the assignment, the solutions, whatever you think should be the connections. Which connection should um, will give the answer. So we have two problems. First is the power uh, lamp, then the
Sensor
sensor, the
output.
buzzer. So
Uh,
which component will get the power? Is it the lamp or the buzzer? So that is the first, and the second one was the obstacle problem which was given.
so it should take a
So,
turn. Wala. Yes.
so you have to think of both the problems and start with the basics with the students. Don't directly give them kits to play with. Start with the theory first, then go with the kits uh, as we were also discussing. Otherwise, it will be in a haphazard manner. The theory should be very clear. Then they will know what to use. Otherwise, they will randomly pick up parts and start playing with it. So we want to teach it as a curriculum, not as a play or a fun activity, just like that.
It is not a toy.
Yeah,
That's
yeah.
the important difference. In fact, sir, just I wanted to get to your attention and for the teachers also. So what we have done. So now this week, this thing is coming, right? Independence Day is coming. So this we are doing it every week, but especially for Independence Day, now we have come up with this. Just 1 second. Uh, ah, Achha, I have it on the app. 1 second. So we what we do, we have these kind of challenges which we give to the teachers
Okay.
and student community alike, where we come up now challenge. So what I mean by challenge, I'll explain. In curriculum, all the activities are like follow along. So the step by step of the activity is given, the objective is known, and then it's easy to follow along because stepwise is defined. So okay, you do this, then you do this stuff like that. But in challenges, the thing is only the objective is shown and maybe
Mm.
some part of the output, and then teachers have to figure it out how it is to be done.
Yes, that is very interesting. Yes, correct.
Yeah. So let me show you the latest challenge, and this I think is very contextual also. Just a second, I'll share the screen.
So challenges will help students to and teachers to think about what they can do to solve the problem. It will be more creative and imaginative.
Correct. Can you see my screen, everybody?
It is still black, Abhishek, same as last
I'll
week. Maybe
stop
share it
sharing
again.
again. Yes, yes. Second. I think because it's not the app, na, it's giving
Yeah,
problem sometime. Can you see it now?
it is still black actually. It says Abhishek has
Second.
started screen sharing double. Yeah, yeah. Now it's okay. Now I can see it. Yeah.
Okay. So this is the Bitbox app, and the challenge that I was talking about. I don't know again that whether you can hear the audio or not, but I'm just showing the challenge visually. Can you hear the audio?
Okay. Can you increase the volume a little bit
Yes,
of the
yes.
audio? Maybe. Yeah. Can you play it now?
A very happy Independence Day to you
Yes,
all.
we can
Yes, we
hear.
can. For a special occasion, we have come up with a special mini challenge, and that is a flag hoisting robot. Typical flag hoisting arrangement
Okay. So this is the GIF.
has a rope and groups of pulleys support the rope. Flag is attached to the rope such that the pulling of the rope down on one side pulls the flag up.
Wow, this is very
For
cool.
the challenge, you have to build a motorized set.
Yeah. So this is a challenge. We have to build a motorized this thing.
Abhishek, can you share this link with me? I'll share it on our group with the
Yes, I.
teachers, so we can keep this as a challenge. This looks very exciting actually. Students will like to have it there before 15th August. Already four. Okay, it's fine. 4 days are there, but it's okay.
Yeah, yeah.
They
So
can
you
try
can
it.
give it a try. Yeah.
This looks
So
great actually. Very
thank
exciting.
you. Thank you. So I'll just share the link across. And
Yes.
the thing is, you have to control the motor through a sensor. That's again an important
For
criteria.
Indian trigger, you can only use one motor to make the flag.
Again, the constraint is one motor. You cannot use two motors. And yeah, that's the challenge. And there's a prize also. But I
Okay.
mean, I suggest that you try it for the challenge and not for the prize also.
Only with lots
Sure,
of
sure, sure.
challenge.
This looks
And
great, Abhishek. We'll share it across in the group and with the students also.
Yes.
And
Yes.
thank you so much for conducting this session. And
You're
I'm sure
welcome, sir.
you have established a rapport with the teachers. I can see it, so they'll feel more comfortable next time also when they come. We will make
Yes,
sure that they will have kids next time with them so that they can follow along. But in the meanwhile,
yes.
they'll just practice and start with the theory and the basic set of lectures. And this activity challenge will share with the students.
Yes, yes. In fact, I would love to see if so. I don't know how many teachers are there. I think seven, six teachers, I guess. So I'd
Yes,
love to see six different flag hoisting
yes,
mechanisms
yes, yes.
from
Students
them.
have already made a fan and a racing car in the school when they
Oh,
were kid. That
very nice.
because they started exploring by themselves, but we'll give them this challenge so that they can.
Correct. So now it's relevant also, and
Yes, yes.
it will be fun to see the videos also of how they are making it. Yeah.
Okay. Okay, teachers
Okay.
also, thank you very much for attending. It's a Sunday, but you spent 1.5 hours. I know you might have other things to do.
Yes. Thank you so much for joining, everyone.
Thank you, sir.
Have a good day.
Thank you, everyone. Yes. Bye.
Thank you, sir.
Thank,
Bye.
thank you, sir.
Bye.
Bye.